Hello, our topic is Introduction to Julia. The Julia programming is a flexible, dynamic language appropriate for scientific and numerical computing with performance comparable to traditional statistically typed languages. Julia features optional typing, multiple dispatch, and good performance achieved using type inference and just-in-time compilations implemented using LLVM. It is multi-paradise, combining features of imperative, functional, and object-oriented programming. Julia provides ease and expressiveness for high-level numerical computing in the same way as languages such as R, MATLAB, but also supports general programming. Julia aims to create an unprecedented combination of ease of use, power, and efficiency in a single language. In addition to the above, some advantages of Julia over comparable systems include free and open source, user-defined types are as fast as and compact as built-ins. No, no need to vectorize code for performance. The vectorized code is fast, designed for parallelized and distributed computations. An obtrusive yet powerful type system, elegant and extensible conversions and promotions for numeric and other types, efficient support for Unicode including but not limited to call C functions directly, powerful shell-like capabilities for managing other processes. For the difference, the most significant departures of Julia from typical dynamic languages are the core language imposes very little Julia-based and the standard library is written in Julia itself, including primitive operations like integer arithmetic, a rich language of types for constructing and describing objects that can also optionally be used to make type declarations. The ability to define function behavior across many combinations of argument types via multiple dispatch. Automatic generation of efficient specialized code for different argument types. Good performance approaches that a statically compiled language like C. Here is the figure about Julia micro benchmarks. These micro benchmarks will do test compile performance on a range of common code patterns, such as function calls, string parsing, sorting, numerical loops, real number generations, recursion, and arrow options. So as the figure showed, we can find Julia had the best performance.
I'm going to introduce our data set that we are going to use in our project. We use the homework dataset from our class. There are 393 observations, 9 variables including age, children IQ, gender, systolic blood pressure, diastolic blood pressure, cholesterol, high density lipoprotein, low density lipoprotein, and BMI. 59% of observations are female and 41% of observations are male. 7 of observations are between 40 to 42. 53 of observations are between 43 and 45, and 10% of observations are between 46 and 48.
There are many different types of functions that must be learned in order to perform hypothesis testing in Julia. We must be able to install an integrated developmental environment. We must install prerequisite packages for the analysis we're going to do. We need to successfully read our dataset into Julia, perform 1 and 2 sample t-tests, and create basic plots for our t-tests. And just to clarify, 1 sample t-tests find the difference between a sample average and a hypothesized average, and 2 sample t-tests find a difference between the averages of 2 samples. In our case, we're going to find the difference in average between male and female blood pressure. The original Julia user interface is very basic, so it is very helpful to have an integrated developmental environment to help you analyze and organize your data. For our project, we will be using the Juno environment in Atom, but using the environment in Julia Pro will also work. Be sure to install Juno. Go to File, Settings, and in the Install tab, you can search Juno, and Uber Juno will appear, which will install the Juno environment in Atom. Since our project is about 1 and 2 sample t-tests, we want our introduction to explain some of the basic functions that can help you perform hypothesis tests in Julia. The 5 packages we ended up using were data frames, stat plots, hypothesis tests, distributions, and plots. Data frames helps us deal with tabular data. Stat plots and plots gives us functions that help us graph our data. Hypothesis tests simply implements a wide range of hypothesis tests that you can use, and distributions gives us functions associated with probability distributions. To read in data from a CSV file, use the function read table. Before running this code, make sure you have your CSV file in your working directory. Your working directory can be selected using Julia, working directory, and select. Our data has successfully been read into Julia. Let's say we want to perform a 1 sample t-test to determine if the mean cholesterol level in our sample is equal to 185. We can subset our data by creating a vector that contains the value of the variable cholesterol for all 393 people in the sample. Using the function 1 sample t-test, we can implement the vector that we just created and decide what our null hypothesis is. We wanted to determine if the mean cholesterol level was equal to 185, so we should put 185 as our null hypothesis in our function. When we run this line, we get a confidence interval and a hypothesis test. But with this t-test, we can derive different confidence intervals by changing our alpha level and number of tails. If we want a different confidence interval, we can use the confident function, and we can change our alpha level and our number of tails to get different confidence intervals. Let's say we want to perform a 2 sample t-test to determine if there is a difference in mean SBP between males and females. To subset our SBP values into a male and female group, we create 2 data frames, one with only males and one with only females. In this code, keep in mind that health is the name of our dataset, and gender and SBP are variables in our dataset. Once we've subsetted our data, we can change our data into vector form with this line of code. This gives us our male and female SBP values in 2 separate vectors. We can visualize our data with basic plots with familiar functions such as QQnorm and boxplot, where we can see why it's obvious that our 2 sample t-test had a rejected null.